Alright, in this segment we're going to be looking at the rock cycle, looking at the three major types of rocks, how they form, how they can interchange between each other through heat and pressure, the combination, and then some examples, getting into some minerals, those types of things. So let's go ahead and get into it. We have three major types of rocks: igneous, sedimentary, and metamorphic. And they're going to be different based on location, where they form on the Earth's surface or within the Earth's surface, and different based on chemical composition. Focusing on igneous rocks first, igneous rocks are going to form straight from molten rock, usually lava or magma. Remember, lava is when you have magma that breaks the surface of the Earth and it is flowing on the top of the surface. It is interacting with the atmosphere. So it's going to be called lava. It will be magma when it is underneath the Earth's surface and is not coming in direct contact with the atmospheric gases. You have this lava or magma. It's going to cool and harden, and that's how your igneous rocks are going to form. Depending on the materials that are going to be within the particular molten rock at the time, depending on its location, depending on how much pressure is added to it, will determine the type of igneous rock you can have form. Some examples of igneous rocks would be granite. Granite would be a type of igneous rock that is going to form underneath the Earth's surface. Anytime you have an igneous rock that forms underneath the Earth's surface, it is going to be considered intrusive. Anytime you have an igneous rock that forms on top of the Earth's surface, it is going to be considered extrusive. Granite would be an intrusive igneous rock. It's an example of some rocks that would be extrusive would be like scoria, pumice. Those two could be used for uses as foot scrubs, for examples. Granite could be a type of material used in tombstones, arrowheads. Mount Rushmore was carved from granite. Another example would be obsidian, and we've looked at all of these types within our notes before. Obsidian is the black glassy one that forms on the Earth's surface as well. The next type of rock that can form is going to be sedimentary rock. Now, sedimentary rock is not going to form through a chemical process. It is going to form through a physical process. That's through weathering and erosion. Remember, weathering is the breaking down of rock, soil materials, breaking them down into smaller pieces. This breaking down process is going to occur through the movement of wind, ice, or water. And then erosion is going to be the movement of these sediments or these particles once they've been broken down, and erosion is going to move them and deposit them into another area. So that's the big difference between weathering and erosion. So your sedimentary rocks are going to form when weathering and erosion occurs. It's going to break down a previous rock, whether it be metamorphic or igneous or another type of sedimentary, break it down into smaller sediments, and then move it through erosion to a new place, layer it, glue them together through water and other chemicals when water evaporates, and then you get sedimentary rocks that form as a result. Some examples: sandstone is a very common example. You can find sandstone in a lot of different places. Parts of the Grand Canyon are going to have sandstone in it. Most of the minerals from sandstone are going to be sand particles, usually made out of quartz and feldspar. Conglomerate's going to be an example of sedimentary rock. You're going to have these larger chunks of rock that are going to be embedded or cemented, kind of like cement would be. And then limestone. Limestone is an example of sedimentary rock where you get calcite mineral that is layered. Usually it's going to form on the ocean floor or seabeds, and then after water evaporates, you get this limestone rock. It can also still be there if water doesn't evaporate, but that would be a good location of where you might find limestone. Limestone is also a type of rock that is forming that forms the different coral reefs. The coral are going to produce a limestone calcium carbonate rock, and that is going to be the base of the bedrock of coral reefs as well. Here are some uses. Our sidewalks, our highways, are common types or common uses for our sedimentary rocks. The Hoover Dam was built using sedimentary rock, and then actually are certain types of sedimentary rock, like for example conglomerate. There's a type of Pottsville conglomerate found up in the Northeast that is going to be some of the hardest type of rock found, and it's found in certain mountain ranges in the Appalachians, and they do a lot of mining out of that particular rock. All right, our third major type of rock are metamorphic rock. So we have igneous, that forms when lava or magma cools. Depending on the type of material in it, it's going to form a different type of igneous rock. Sedimentary rock is going to form from weathering and erosion, so the physical breaking down of rocks. And then metamorphic rock is going to form when you take a particular rock, whether it be igneous or metamorphic or sedimentary, and you're going to get a lot of extreme heat, high extreme heat, and tons of pressure are going to be applied to these rocks, and that's going to cause them to metamorphose or to morph into a completely new type of rock. It's going to change the physical composition, and it's going to change the chemical composition of these rocks, and that's what it means to form a metamorphic rock. The big key is changing the chemical composition, not only the physical but the chemical composition, and it requires extreme heat and pressure. So further down in the Earth's surface, or further down in the Earth's crust into the mantle, is when you're going to be looking at a lot of these metamorphic rocks forming. Sometimes 3 to 4 miles down below the Earth's surface is where you get a lot of this occurring. Some uses, monuments, memorials are good uses. Some examples of metamorphic rock. Quartzite would be an example of metamorphic rock. A lot of heat and pressure is going to change quartz, which is a mineral, into quartzite. You can get gneiss. Gneiss is a type of metamorphic rock. When you have granite that is highly pressurized, it's going to cause granite to change into gneiss. So those are a couple of examples for you. You can take shell and pressure and heat, extreme heat and pressure, and change it to slate, and that would be an example of a metamorphic rock as well. So here's just a nice list, a breakdown for you of some common types. Igneous, I mentioned obsidian. Granite is a common one. Quartz, you can have quartz rock that forms straight from quartz minerals, but then you also have a quartz mineral quartz is going to be one of the major fundamental minerals that are going to form a lot of these rocks. Metamorphic, I mentioned quartzite. Marble is another good example. There's gneiss. Schist is going to be one. And then sedimentary, you've got sandstone, limestone, conglomerate. Those are some of your common ones as well. Now, focusing on the rock cycle, this is something you definitely want to make sure that you're comfortable with. With these rocks within the rock cycle, if you want to say there's a beginning, it could be with the magma, that molten rock underneath the Earth's surface. But depending on how it cools, or if it gets pressurized, or if it makes it to the Earth's surface, and through weathering and erosion, you're going to get its ability to change into the different types. So depending on the force acting upon these rocks, they can pretty much change into in any direction within this cycle. So there's not just one particular way the pathway moves, but this is a nice little snapshot. You're looking at magma that can cool, and then it forms an igneous rock. Maybe that magma makes it to the surface, and it turns into lava, and then it cools into an igneous rock. That igneous rock could go through a lot of heat and pressure and change back into a metamorphic rock. That igneous rock can be broken down through weathering and erosion and change into a sedimentary rock. Sedimentary rock, once again, it can be melted straight back into magma. It could be heat and pressurized into metamorphic. Metamorphic rock can be heated up to magma. It can be pressurized into a different type of metamorphic. Or it could go through weathering and erosion and change back into a sedimentary rock. So depending on the forces that act upon the rocks can determine which way you move within the rock cycle.